So now we come to the strain. Okay, so if we talk about the strain, what is a strain? Strain is just a change in length upon original length. I mean, before the taking the test, you have your gauge length. Gauge length means what the kind of the LO. LO means this gauge length. See here, this particular length. This particular length is known as your gauge length, and that is your LO, L original. Okay, so change in length by original length. Now you can write the change in length like initial, instantaneous. I mean the final length minus original length. This instantaneous length means the length that is now after the taking the test. What the length that you are now? Obvious that would be bigger than of original because you are pushing. You are pulling the member, pulling the specimen. If you are pulling the member, then definitely your length or length of the member will get increased, and at the same time your cross section area will get decrease. Okay, so final length minus initial length upon the initial length. Okay, this particular ratio is known as your strain. It is just a ratio how the member has increased, the member specimen length has increased as compared to the original length. This is the simple meaning. Okay, so how? I mean, change in length means what? How? I mean, the ratio of, the strain means the change in the length, overall the change in length of a specimen as compared to the original length. Okay, this is your, and obviously this is a unitless quantity because if you can see at the numerator you have a length which has a unit meter, and at the bottom you, or you can say in denominator you have the length as well which has a unit also meter. So meter upon meter get cancel out, meter upon meter get cancel out. What you are left with? Nothing. It means the strain is a unitless quantity. Keep in mind. Okay, the same thing has written here over here. Okay, now now I will discuss the things that we have left here. Yeah. So as you know that, I mean, whenever you applied the force, a load, you get a stress because the force per unit area is known as your stress, and due to this stress there is a strain as well. Okay, so strain, so strain is just a change in length by original length. Okay, this is your strain. Similar to the torsional, if we talk about the torsion test, then shear strain. I mean everything. I mean if we talk about the simple stress, it is a, either it is a compressive or tensile. But we have additional term which is known as the shear. It means you have applied the force parallel to that cross sectional area. Okay, so in that case you have a shear stress and shear strain. Shear stress, the value is the same as we have written here, force upon area, and the shear strain, if we talk about shear strain, it is denoted by the value gamma. And how you can define that? Just the angle. I mean how the angle they have moved. See here, it was like this. If you can think about the first one, the first image, this image, this image. Okay, so it was the original. Now you have applied the force in that way. This is the question, this way. So at the bottom, obviously you are applying at the same time. I mean, shear stress comes with the complementary. You have applied the force this way, and at the bottom this way. So this particular, suppose, think about, I mean, this particular portion is at constant. This it fixed. You can see, you can have the idea that the bottom part is fixed. If bottom part is fixed, now you are applying the force in this way. What will happen? This will get tilted little bit, right? I mean, initially it was like this, right? But now due to the force, they have tilted, they have moved a little bit ahead. So there is the gap in between the original and the final position. This gap is measured by the angle, and that angle is known as your shear strain. So this angle having the value theta, this this theta is known as your shear strain. Okay, so in a normal tension or a compressive test that you have the easy, you can just measure the length. Okay, and after the test you can measure the length. The difference of this length, this is your increase in length, and that increase in length, if in case it is a compression, then decrease in the length. So whatever the changes in the length divided by the ordinal length, this is your strain. But in case of the shear, if you talk about the shear, then you have to measure the angle. Okay, how much angle they have moved as compared to the, I mean, if you can just think about the I mean the top face, and this is the bottom face. So how much the top face has moved, okay, as compared to bottom face. So this will make an angle. That angle is known as your shear strain, which is denoted by gamma. Okay.